Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to solve GATE 2025 problems for the topic circuits and networks. For that, I have taken the problems from electrical discipline and electronics discipline from GATE 2025. Let me start solving the problems. So this is the first problem I have taken from electrical paper. First, let me read out the problem. The IV characteristics of the element between the nodes X and Y is best depicted by. So here is the circuit given. For that, we need to find the relationship between current and voltage. IV characteristics. Okay. So let me observe the circuit. So only we are having one current source and one resistance between the terminals X and Y. So only one current. So this is the IXY. So IV characteristics is nothing but we need to find the characteristics between characteristics of IXY and VXY. IXY is the current through IXY is the current given here and VXY is the voltage across the terminals XY. Okay, so this is VXY. Okay. So for this, I am going to apply the Kirchhoff's current law. Okay. So Kirchhoff's current law, I am taking this as node. We know the Kirchhoff's current law, sum of incoming currents to the junction equal to sum of outgoing currents. So now IXY, this is the IXY, it is in the forward direction. So this is incoming current. IXY is the incoming current. And this 1 amps is the outgoing current. It is away from the node. So this is outgoing current. And then current through 1 kilo ohms. So that is also outgoing current. Okay. So let me write the equation for that. So by Kirchhoff's current law, I am going to write the equation. Sum of incoming currents, only one is incoming current. So IXY. And then outgoing currents are 1 amps is one outgoing current. And then current through 1 kilo ohms is another outgoing current. So current through 1 kilo ohms we can find out by dividing the voltage across the terminals VXY by 1 kilo ohms. Okay. So IXY minus 1 equal to Vxy by 1 kilo ohms. Okay, so therefore Vxy equal to 1 kilo ohms into Ixy minus 1. So let me take this equation as consideration to find the characteristics. So we need to find the characteristics. Now observe the options. Now observe the options. The options in the option A, we are having 1 amps at Vxy equal to 0. So we need to find the variation of current with respect to the variation of voltage. So at Vxy equal to 0, we are having 1 amps. And here also in the option B also 1 amps. In option C, we are having 0 value. In option D also, we are having 1 amps. So first let me check whether it is 0 or 1 amps. So let me check with the voltage equal to 0. Okay. So first I am putting Vxy equal to 0 volt. So when we apply here in this equation, 0 equal to 1 kilo ohms into Ixy minus 1. So therefore, Ixy equal to 1 amps. So we got 1 amps for Vxy equal to 0. So let me check with the other value also. Okay, when Vxy is increasing, what will happen for the current? That also we have to check. So because different types of characteristics is given, in option A, constant value is given. In option B, increasing characteristics is given. So and then in option C is already wrong only because we didn't obtain 0. We didn't obtain 0 amps. So option C is wrong. So we need to check whether current is increasing or current is decreasing with respect to the variation in voltage. So let me check with that. Now I am taking Vxy equal to 1 kilovolt. 1 kilovolt because we are having resistance value equal to 1 kiloohms. So I am taking that Vxy equal to 1 kilovolt and I am applying here in this equation only. So 1 kilovolt equal to 1 kilo ohms into Ixy minus 1 and this will get cancelled and it will become 1. Already here minus 1 is there. So IXY equal to 1 plus 1, 2 amps. So we will obtain 2 amps for 1 kilovolt. Okay. So when VXY is increasing, IXY changes from 1 amps to 2 amps. That means IXY is increasing with respect to the variation in VXY. So therefore, the option B is the correct characteristics for the given network. Option B is the correct characteristics for the given network. Okay. Shall we move to the next problem? Okay, let me start the next problem. So this problem I have taken from EC paper. So previous problem I have taken from EE paper and this problem I have taken from EC paper. Let IC, IL and IR be the currents flowing through the capacitor, inductor and resistor respectively in the circuit below, given below. The AC admittances are given in Siemens. Which one of the following is true? Okay. So they have given the current value through the capacitor and through the inductor and through the resistor also. So we need to find each current values. Okay. So already admittance value is given. So let me write Siemens. Siemens is admittance unit. So let me represent this is YR and this is YL and this is YC. Okay. Okay, this is total voltage, 1 angle 90 degree. Okay. So we need to find IC, IL and IR. Now, so this is the basic AC network. So here total voltage is 1 angle 90 degree. Okay. Here all the passive elements value are given in rectangular form. Well, shall we convert into polar form first? So here YC is given as, here YC is already given as J.25. So when we convert this into polar form, 0.25 is the magnitude because 0.25 is the magnitude. 0.25 is the magnitude because a real part is 0. So real part is 0 means root of 0 square plus 0.25 square is nothing but 0.25. So 0.25 is the magnitude. So when we want to find the angle tan inverse B by A. So tan inverse B is imaginary part. So 0.25 by 0. So tan inverse anything by 0 is tan inverse infinity. So tan inverse infinity we know that is angle 90 degree. So we converted YC equal to YC in the polar form. Like that we can convert for others also. YL equal to minus J.1. So 0.1 is the magnitude. So minus J. So we can represent that as minus 90 degree. Okay. And then YR, no magnitude. No angle, only 0.2. Okay. Okay. So let me find the current flowing through the resistance, inductance and capacitance. So let me find IC. So we know voltage by impedance equal to current. So we can convert that into admittance form. So V into YC. Here total voltage is 1 angle 90 degree into YC is in the polar form 0.25 90 degree. So we know 1 into 0.25 0.25. Argument can be added, that is 180 degree. Okay. And current through the inductor IL equal to VYL, which is 1 angle 90 degree into minus, 0.1 minus 90 degree. So when we multiply this 1 into 0.1, 0.1 and then angle 90 degree and here minus 90 degree, it will become 0 degree. And current through the resistor V into YR, which is 1 angle 90 degree into 0.2. So that is 0.2 90 degree. Okay. So we got the answers for current through the capacitance and inductance and resistance. So let me check with the option. So see the option A, IC equal to 0.25 angle 180 degree. And here also we obtained that same. IL equal to 0.1 angle 0 degree. And here also we obtained that. And IR equal to 0.2 angle 90 degree. We obtained that only. So option A is the correct one for the given question. Let me move to the next problem. So this problem is taken from the two-port network. This problem I have taken from the EC paper. The Z parameter matrix of a two-port network relates the port voltages and port currents as follows. Okay. Z parameter matrix of the network shown below is. Okay. So here the network is given, options are also given. We need to find the parameter matrix, Z parameter matrix. The topic is two-port network. From that Z parameter, we need to find the Z parameter matrix. Okay. So the given network is pi network. So if we convert that into T network, it will be easy to find the Z parameter. So normally for Z parameter, we need to write the equation like this. So this is V1 by V2, V1, V2 with respect to the terms of I1, I2. This is the Z parameter, Z11, Z12, Z21, Z22. Where Z11 is the input impedance, Z22 is the output impedance, Z12 and 21 are the transfer impedances into I1 by I2. So we need to find this matrix value, Z parameter matrix value. Okay. So let me convert the given network into T network first, and then it will be easy to find everything. So pi network is nothing but delta network. So delta to star transformation we can use, or delta to Y network. Okay, delta to Y network. So here all the resistance are in equal value. So we can find easily. So to find this resistance, either side resistance product by total resistance. So 2 into 2, 2 into 2 by 2 plus 2 plus 2, that is 6. Okay, so 2 by 3 ohms. So the equivalent resistance in each ohms will be 2 by 3 ohms. So this is 2 by 3 ohms and this is also 2 by 3 ohms. Now I am drawing the equivalent network here, equivalent star network. So see, already we are having 2 ohms, and after conversion, this one. So the network will be like this. Voltage at the port 1 is V1 and current at the port 1 is I1. And here voltage at the port 2 is V2 and current at the port 2 is I2. And here after conversion, this will become 2 by 3 ohms, and here also 2 by 3 ohms, and here also 2 by 3 ohms. And this is 2 by 3, sorry, this is 2 ohms. Okay. Now, so we can write the loop equation. We can write the loop equation. Now, I1 is the first loop current. So for first loop, we can write the equation for first loop. This is I1 current. So 2 plus 2 by 3 plus 2 by 3. 2 by 3 plus 2 by 3 is 4 by 3. 4 by 3 plus 2 is 10 by 3. I think it's 10 by 3. So 10 by 3 I1 plus, because current is in opposite direction, 2 by 3 I2 equal to V1 by Kirchhoff's voltage law. Okay. So this is for L1, loop 1, and then for L2, loop 2 also, and this current at the port 2 is I2. So 2 by 3 I1 plus total is same value, 2 plus 2 by 3 plus 2 by 3, that is 10 by 3. 10 by 3 I2 equal to V2. Okay. Now let me write in the matrix form V1, V2 equal to, what are the coefficients of I1 and I2? 10 by 3, 2 by 3, and here also 2 by 3, 10 by 3 into I1, I2. So this is the Z parameter matrix. Okay. So 10 by 3, 2 by 3, 2 by 3, 10 by 3. So let me check with the options. So in option A itself, we are having that values. So option A is the correct one. Option A is the correct one. Let me tick out with the option A. So like that we can find the Z parameter matrix. Okay. All the values of Z parameters. Let me move to the next problem. So this problem I have taken from electrical paper. 3 problems I have taken from electrical paper and 2 problems I have taken from easy paper. In the circuit shown below, if the values of R and C are very large, the form of the output voltage for a very high frequency square wave input is best represented. So this is asked from the topic AC network, and here Vin is given as square pulse. So we need to find the output voltage waveform for this network. So this is nothing but RC network, and here we need to find the waveform for output voltage. Okay. So for that, I'm going to convert that into. So if we know the equation for the output voltage, we can directly find. Otherwise, we can convert to S domain and we can find the inverse Laplace transform. So here, let me convert that into S domain. So if we convert that R, and this will become 1 by Cs, and here I am taking this input voltage as VA of S, and here I am taking this output voltage as V naught of S. Okay. So let me find the value of V naught of S. Let me find the value of V naught of S. So how can we find the V naught of S? V naught of S is the voltage across the capacitance. Okay. So if you want to find the voltage across any passive element, we can use the voltage division rule because we are having input supply voltage. By using that, we can find the output voltage. So by using voltage division rule, I am going to find the equation for output voltage. Okay, so V naught of S equal to VA of S into that impedance by the total impedance. Okay. So VA of S. So 1 by CS by RCS plus 1 by CS. This will get cancelled. And then I'm taking 1 by RC outside. Then it will become 1 by S plus 1 by RC. Okay. So now 1 by RC is constant. Okay. So 1 by RC is constant. Now by taking inverse Laplace transform, V naught of t equal to VA of t. This 1 by RC is constant, and then inverse Laplace transform of 1 by S plus A is, it is nothing but exponential, e power minus t by RC, where RC is the time constant. Okay. Now, no need to find the time constant and all because we need to find the waveform only. So let me check with the options. So here, see the input voltage. It is varying from minus 1 volt to plus 1 volt. So let me check with the value. So when we put VI equal to 1 volt, VA equal to minus 1 volt. So when VA equal to minus 1 volt, what will be the characteristics? See, when VA equal to minus 1 volt, then this will become minus 1 by RC e power minus t by RC. So e power minus t by RC is, it is a decaying exponential equation. Okay. So it will be in decaying exponential, but we are having negative of decaying exponential. That means it will be like increasing exponential only. So the curve will be like this only. From minus 1 volt because we are having the negative value. Okay. So minus 1 by RC of e power minus t by RC. So this will be increasing exponential. Negative of the decaying exponential is nothing but increasing exponential from minus 1 volt. So again, if we put plus volt, I'm writing here I'm writing here, if VI equal to minus 1 volt, it will be like increasing exponential because we are having minus 1 by RC e power minus t by RC. Okay. So when VA equal to 1 volt, it will become 1 by RC e power minus t by RC. It is nothing but decaying exponential. So curve will be like this. So let me check with the option. The first option is triangular waveform. Second option is square waveform. And here, see here, in the third option, we are having like increasing exponential and decreasing exponential from minus 1 volt to plus 1 volt. So we can tick out with the option C. So option C is the correct waveform for the output voltage for the given network. Okay. Shall we move to the next problem? So this is the last problem I have taken from electrical paper, and this the topic is magnetic coupled circuit. Magnetic coupled circuit. Okay, let me read out the problem. Consider two coupled circuits having self-inductances L1 and L2 that carry non-zero currents I1 and I2 respectively. The mutual inductance between the circuits M with unity coupling coefficient. The stored magnetic energy of the coupled circuit is minimum of which of the following values of I1 by I2. So for the magnetic coupled circuit, we need to find the stored magnetic energy. We need to find the equation for stored magnetic energy, and then at which values of I1 by I2 the energy is minimum. That also we have to find out. Okay. So let me write the energy equation for that. Energy equation for coupled circuit is nothing but E equal to half L1 I1 square plus half L2 I2 square plus M I1 I2. Okay. M is the mutual inductance, L1 is the self-inductance, L2 is also self-inductance. So here, now we have to find out at which values of I1 and I1 by I2 the minimum. So for that, I'm going to differentiate the energy equation with respect to I1. So first I'm going to differentiate with respect to I1. Okay. So after differentiation, it will become 2I1. So 2 get cancelled and it will become L1 I1 plus, and this is a constant, it will become 0. And then with respect to I1 means M into I2. So this should be equated to 0 to find the minimum value of ratio. So if it is equated to 0, it will become L1 I1 equal to minus M I2. So I1 by I2 ratio equal to minus M by L1. So this is one answer. Okay. With respect to I1. So like that, if we differentiate with respect to I2 for the energy, with respect to I2, so it will become same L2 I2 plus M I1 equal to 0. If it is equated to 0, so L2 I2 equal to minus M I1. So therefore I1 by I2 ratio will become minus L2 minus L2 by M. Okay. So this is another ratio. So this question is MSQ type question, multiple select question type. So here two options may be correct. So one answer is minus M by L1, that is in option A. Other answer is minus L2 by M. So that is in option D. So here option A and option D are correct. Option A and option D are correct. Okay. So thus we solved 5 problems from the circuits and networks. Okay. Circuits and networks. Thank you very much. And this is Mani's Gate Tech Vision. This is a channel for engineering lectures. You can subscribe. Thank you very much for watching the video. If any queries means you can mail me. Thank you.